All right, everybody. Hope we're doing well here. So, as I mentioned in class, I wanted to go over parts A and B with you all together. So, just as a quick review, if we remember from class, I did say that this, as itself, is an apothegm. So, this is the apothegm. And the 11 here, this is not the apothegm. We can't really say that it is a radius of the shape, but we'll just say that it is, just a different segment. So I'm going to do part B first, and then I'll do part A, because we want to be able to draw right triangles here. So I'm going to go ahead and draw two lines that connect from the center to these points. So we know that the height of this triangle is 5. So I'm going to sort of blow up this triangle here. I'm going to make a bigger triangle. And this is just going to be the right side, right half of this triangle here. That's all we really need. We just need this little height here. So this is 5. The right angle is here. And so the first thing whenever you're doing this kind of question is you want to figure out what is the central angle. And so we said that this was a decagon, so there's 10 sides. So to find the central angle, it would be 360 divided by 10, which is 36 degrees. But when we split this into two triangles here, there's two triangles, the central angle gets cut in half. So instead of 36 as the whole thing, we only care about half of it. So it's going to be 18 degrees here, which means that this other angle is going to be 72 degrees. Now, I mentioned that this, like solving for area of regular polygons is tricky because it involves trig. And so I know we haven't done trig in a long time, but hopefully this will be of good use. So the most important things in this right triangle is the height and the base. We'll call this x. So if I'm trying to find x and I'm given the height of this triangle, I want to use tangent here because I don't care about the hypotenuse. Obviously for like part A, the hypotenuse will come in handy and we'll probably have to use a different ratio then. So what I'm going to do is I'm going to use 18 degrees as my reference angle. This is opposite and the 5 is adjacent. So to set up a trig equation here, it would be tangent of 18 is equal to x over 5. So to solve for x, just multiply 5 on both sides. And so for x, let me plug this into my calculator here. So for me, I would get 5 times 18 and then press tangent. And you press enter, you should get 1.62. So 1.62 is going to be x. So x equals 1.62. But that's only half of this triangle, right? I need the whole base because if I want to use the equation that we figured out, which is area is equal to 1/2 times the perimeter, capital P, times the apothegm, we need at least one side length. So if this is 1.62, I'm going to just multiply this number by 2 to get the whole base of the triangle. Do that, I get 3.24, but if I round it, it does become 3.25. So the whole side length here is 3.25. So this matters because there's 10 sides. So when I'm trying to use this formula, here's how it's going to work. It's be 1/2 times 3.25 times 10. And why is it 10? Well, because there's 10 sides. And since it's a regular polygon, all the sides are the same. So I just need to multiply this number by however many sides there are. And then we also multiply by the apothegm, which we know in this triangle is 5. 5 is, again, the apothegm going straight up and down from the center of the polygon to the side. And so when we start multiplying this all together, this would be 32.5 times 5 and then times 1/2. And so, again, this is really all calculator work here. So if I do 32.5 times 5 divided by 2, I end up getting an area of about 81.25 units squared. Okay. So that's the area of part B. That's with the apothegm given to you. Okay. Now, part A is a little different because we have to do a little more work to find the apothegm. I need to figure this out here. Now, I know that this is also made as well. This is 11. So again, I'm going to blow up this triangle here. I'm going to make it the same triangle as the one on the right. Okay, so this is 11. This is a right angle. And this one, if we count, it should have 9 sides, hence a nonagon. So if I want to figure out what the central angle is, I need to do 360 divided by 9, which you should get 40 degrees. So if the whole angle is 40 degrees, half of that is going to be 20 degrees, which is this little small angle right here. So that means 20 degrees is here. And if this is 20 and this is 90, that's 110. So 180 minus 110 is 70 degrees. So in this case, I need to solve for both the apothem, which is the height of this triangle, and the base of this triangle. So in this case, you have a choice. You can either use sine or cosine. I'm going to make my reference angle be sine, or 70, which means I'm going to use sine to solve for x. Actually, I'm going to call it a for the apothem. And then we'll call the base x. So I'm going to use sine. Sine of 70 is equal to a over 11, because it's opposite over hypotenuse. So I multiply 11 on both sides. And so when I do that, my calculator, bring it back up here. 11 times 70 sine equals, you should get about 10.34 as your apothem. So A is equal to 10.34. And then might as well just use trig again. And in this time, use cosine of 70 to find x. So might as well change the color here. Okay. So cosine of 70 equals x over 11. Multiply 11 once more. And so I'm going to do the same thing, 11 times 70, but instead of sine, I'm going to use cosine. And you should get 3.76. So that's important. So x equals 3.76. But I need the whole side length. I need the whole base of the triangle. This is just half of it. So I'm going to multiply this number by 2. Should get us 7.52. So 7.52 is the side length of this nonagon. So now I'm going to use the formula here. So area is equal to 1/2 times the perimeter. So perimeter is going to be 7.52 times 9, because there's 9 sides. And then the apothem is times 10.34. So lots of calculator work here. So I'm going to do 7.52 times 9 times 10.34. And then I'm going to divide by 2. You should get an area of about 349.91 if we round to the nearest hundredth here. So it equals 349.91 units squared. So hopefully this helps. Tomorrow we're going to keep practicing and go over a couple more examples of regular polygons. And yeah, hopefully this will be good for us. So if you guys need any more help, please email me or come to office hours tomorrow afternoon. Have a great day, and see you tomorrow. Bye-bye.